All right. So in section 5.3, we'll be talking about some new formulas. These formulas will cover the double angle, power reducing forms, and then half angle formulas. And we'll see how we can apply these formulas as well. And some of these formulas are straightforward from the last formulas that we have, like cos alpha plus beta, sin alpha plus beta, or tan alpha plus beta. Then let's look at the formulas for the double angle first. Now here, the double angle means twice theta, 2 theta, 2. So you see here we have three formulas here written for sine, cosine, and tangent, and all those are sine 2 theta, cos 2 theta, and tangent 2 theta. But the interesting is, all these formulas, none of the formulas are new to us, because these formulas are coming from all the previous formulas like this. Because if you just write sine 2 theta equals to sine theta plus theta, okay, you can always write sine 2 theta equals to sine theta plus theta. If you go to the back of the formulas page, you will get those formulas. If you'll see at the back, at the very end of the right bottom corner, you'll see some formulas for the double angles. Page number 4 in the formula sheet. Now, here, see the sine theta plus theta. Sine 2 theta is nothing but just we break it down to sine theta plus theta, and the rest is simple because we just applied the formula we had in the previous chapter. Because once we have it, the rest is simple, and then we'll get into that point. Okay, same we did for cosine and tangent. If you look at here, for cosine 2 theta, we just assume that that's basically theta plus theta. Once you have theta plus theta, we applied the formula from the last chapter, which was the cosine alpha plus beta. Remember the formula from the last section? We just applied that formula here, and we get into here. So that's, again, we are applying the same formulas from the last chapter, but right now it looks different because after you apply the formula, your answer is different. So tangent 2 theta, we did the same thing from the last section, because we wrote the tangent 2 theta equals to tangent theta plus theta, and the rest is simple. We just applied the formula for tangent alpha plus beta. And all this for three formulas we had in the last section. And now, as a summary, these are the three formulas, but remember the cosine 2 theta, which is cos square minus sine square, can be written in another two forms. That is still the same formula, but they can be also written in these forms. If you look at these three formulas, all of these formulas are exactly the same formula, but they can be written in another forms because of this. Because you probably remember that sine square, there was an identity which was sine square theta plus cos square theta equals to 1. Do you remember that formula? Sine square theta plus cos square theta equals to 1. Okay. From that formula, I just wanted to make sure that we understand how we get here, or how we are, because none of these formulas are like fundamentally original formulas. These are some kind of derived formulas because they're coming from some other formulas, and we are just, we just want to make sometimes some things handy because we want to know what is cos 2 theta. So what we did was we just wrote cos 2 theta equals to cos theta plus theta, and the rest is same. We just applied into cos alpha plus beta. But here we also did a little bit, so tweak and twist over that cos square theta minus sine square theta, and then what we can do is, for an example, for cos square theta, we can always, since the sine square theta plus cos square theta equals to 1, you probably remember when we discussed in the previous sections, at some point you remember that we applied something like this. You can write always the cos square theta equals to 1 minus sine square theta, right? It's the same formula. Or you can also do this. You can just write sine square theta equals to 1 minus cos square theta. So you can always write these three formulas. I'm saying the same formula you can write in different forms. So if you do it here, instead of cos square theta, you can always write 1 minus sine square theta. So you have 1 sine square theta here. So from that point, your formula is going to be modified to 1 minus 2 sine squared theta. Now you see why we get that form number 3. And similarly, if you just again cos 2 theta equals to cos squared theta minus sine squared theta. Now if you just replace the sine squared theta by 1 minus cos squared theta here. So what happens? Cos squared theta minus you replace sine square by 1 minus cos squared theta. What happens? You will get cos squared theta minus 1 plus cos squared theta, which is 2 cos squared theta minus 1. So I'm just trying to show you that nothing is new. All these are fundamentally all these are not fundamental formulas. They are coming from our old fundamental formulas or identities, and we are just writing the same formulas but same things still, but in a derived form. Now let's see whether we can apply these formulas. Now you have the formula pages and you have the formulas, and we'll be using all the formulas for the double angles, right? Did you find the double angle formulas at the page number 4, bottom right corner? So since you have plenty of formulas here, and some of the formulas probably you will not need for this class, but as we are covering all the formulas, so you probably, if you want, you can just mark your formulas there so that you will know which formula is from which section, and you can bring it to your test. So make sure you will know which formulas are from which section, or if you want. Now here we have a question here. Now here let's see, your sine theta is given, and you have to find out the sine 2 theta, cos 2 theta, and tangent 2 theta. Now first of all, to find the sine theta, you have to apply the formula, double angle formula for sine theta. But before we do that, one of the things that we probably have to look at here is, okay, before we do that, for the sine 2 theta, let's write the formula first, then we'll probably understand what you need to do. Let's write the formula for the sine 2 theta from double angle standpoint. Let's see, sine 2 theta is 2 sine theta cos theta, right? Did you find the formula there? That's the formula we have also looked at in the first slide. Now at this point, if you look at the right side here, you will need the sine theta and cos theta both to solve this, to basically have your sine 2 theta. So you already know the sine theta, so you don't have any problem with the sine theta, but you don't know the cos theta. So you have to find the cos theta, right? Now, how do you find the cos theta from sine theta? Your formulas are there at the right corner. You can always use those. If you look at the second one, cos squared theta equals to 1 minus sine squared. So you can always use your formula to find the cosine from the sine. So your cosine is going to be, let me do this, because just to be fair, because I don't know exactly what will be the sine at this point, for an example. Okay, let's say I don't know the sine, because the sine theta, cos theta, tan theta, and all of the 6 functions, they have different signs based on which quadrant the theta lies here, right? And if you check the question, that information is also given to you that theta lies in quadrant 2. And you know what? What is quadrant 2? What is positive in the quadrant 2? So only the sine and cosine, they are positive. Everything else, negative. So you know that the cosec theta is going to be the negative one. Okay? But what we can do is, the book has tried a different option. So that's also, I'll also tell that how they tried and what they did. You can also do that. But what I would prefer is, you can just use the cos theta formula, which is 1 minus sine squared theta. And then the sine theta is 3 over 5. So we'll be writing 3 over 5 here, whole square. And if you do the math, you'll come up with 4 over 5. Okay, that's going to be your cos theta, absolute value of the cos theta. Okay, now remember, since the cos theta is in the second quadrant, I'm saying the theta is in the second quadrant, the value of the cos must be negative. So we just try to find the absolute value. So absolute value means without the sign. Okay, now we know that is in the second quadrant. So your cos theta is going to be negative 4 over 5. That's one option. The book, what book tried was, they tried to find these signs from the original formula, which was, remember one day we, in one section, we tried to find the sine cosine in terms of x, y, and r. So we wrote all the formulas in terms of a circle. Remember that? We just, we can also always do that. So we just try to think everything like this, that this is your center, x-axis and y-axis is there, this is your r here, and this is x and y's. So you can assume that there is a triangle, and this is your x, and this is your y, and this is your r, okay? This is your 90 degree. So you can write all the trigonometric functions in terms of this triangle, okay? And then if your angle is here, that's fine, but if your angle is here, then x is going to be negative, right? Because this side x is negative here, right? If you are here, x is negative, y is also negative. If you are here, x is positive, y is negative. So they tried to think from this standpoint, but what I thought is probably that's like starting from the scratch. Maybe instead of doing that, because since we know that we have 4 quadrants and we also know in which quadrant which are positive and negative, we can just get the sine and cosine, and we can just use the sign from our, because it doesn't matter whether you go by the book one or you try my steps, because I thought this might be the easy one, because instead of just doing that, you can just find the absolute value of the sine and cosine, because if you know one, you will know the other one for sure. And then, or use some basic trigonometric identities to get the sine and cosine from the given information, and then you will know the sign of the trigonometric functions for that function just from the information of your quadrant, because it will be always given in the question that where the theta lies. Okay. Now here at this point, the sine is positive and then cosine is negative because you are in the second quadrant. Now you can now apply the values here directly, right? 2 sine theta times cos theta. So just apply the value, because you know the sine is 3 by 5 and then cosine is negative 4 by 5, which is quite simple. You just apply it and you will have your answer ready right away. So if we do this, let's see, 3 over 5 times 4 over 5. So the answer will be it's negative 24 by 25. Is that what you have? We just applied the value of sine and cosine there. Rest is just straightforward. Now, since we have these, can you try to find the other two, the cosine and tangent? Now, in case of cosine will be simple, because the formula for the cosine, what is the formula for the cosine? Cos 2 theta. What is the formula? Check your double angles. There is a formula for cosine, right? So you can either use cos theta and sine theta both to find the cosine, or you can only use the sine theta, or you can only use the cos theta, because there are 3 different forms of the for the cosine 2 theta. That's the only formula in the double angles category which has 3 different forms. Now, based on what information you are given, you can choose your form. But at this point, in this question, any of the forms are okay because you know sine and cosine both. I'm saying that you know the sine theta, you know the cosine theta, so you can apply any of the forms, whichever you like. But in some cases, you probably would prefer one over other. It depends. But now all the three forms are same. Now it's up to you which one you want to use. You have three forms. So try and see whether you can find the cos theta. But in case of tangent, you have to find the value for tangent. Now one option is, since you know the sine and cos, tangent is simple because the tangent is nothing but sine over cos. Okay. Now let's find the cos theta, cos 2 theta first, and then we'll talk about the tangent. Do you have answer for tangent 2 theta? Here, if you do the sine theta over cos theta, you will have your tangent 2 theta, which is negative 3 over 4, right? Negative 3 over 4 for tangent 2 theta, and then you can apply the formula for tangent 2 theta, which is 1 minus cos 2 theta, or you can apply the tangent formula that we got from the last double angles, which is 2 tan theta over 1 minus tan square theta, right? We apply these. We apply this, so you have 2 tan theta, so which is negative 3 over 4, 1 minus negative 3 over 4 whole square. So you have, if I cancel this 4 and 2, 1 minus 9 by 16. By 2 times 7 by 16, 8. Is this negative 24 over 7? Everyone has the same answer? Negative 24 over 7 for tangent 2 theta, tan 2 theta. So make sure you always have the right sign, because our tangent was negative, and you are in the second quadrant, so which is, you know, it should have negative value. So now we will verify one identity here. In the left side of the identity, you have sine 4x. Which is, you know, so one of the things that we might have to think is how we can apply or how we can proceed here. So you have any clue what you can do? Any idea that how we can start? So your left side is sine 4x, x to theta. So if we change the x to thetas, it will be sine 4 theta, and we don't have any formula for sine 4 theta. We have just one formula for sine 2 theta, right? It's actually very simple, but I'm just asking you so that I can just see whether you can think and find something which might be But you know, you just have one formula and you have to apply that formula, which is sine 2 theta. Now what you can think is you can write sine 4x as sine 2 times 2x, right? That's the 4x, right? I'm saying 2 times 2x. Now you can think this 2x as your theta. If you do it, you can now apply the sine 2 theta formula. That's what I'm saying. At this point, your 2x is going to be your theta. So if you have that, how the formula look like? If you apply the formula, which is, what is the formula for sine 2 theta? 2 sine theta times cos theta, right? Now here the theta is 2x. So I'm going to write make sure you understand what we did. I just, I'm still writing the same formula, but at this point the theta is 2x. So that's why I replaced the theta by 2x. That was our original. So what is the original formula? Original formula was sine 2 theta equals to 2 sine theta times cos theta. So I just, we just assume that the theta is 2x here. Now at this point, to proceed further, you will need sine 2x from here, and you will also need the cos 2x. Okay. Now remember, sine 2x itself has a formula, right? Which is 2 sine x times cos x. And 2 sine x times cos x, and cos itself has a cos 2x itself has a formula. So let me write those formulas for sine 2x and cos 2x. Because if you look at the right side of the identity, you see that in the right side all of those are x. You see right side, all of the angles are x. So we are not there yet because our angles are still 2x. But if we apply the formula again, every time you are applying the formula, if you look at carefully, your angles are getting half. Because what happens, if you look at the original formula, look at this. In your formula, the angle was 2 theta, but in the right side, the angles are getting half. Do you see that? So every time it's something like this. So even if you look at the step we are in right now, your angle was 4x, but once you apply the formula, your angle became 2x, and that's why this is called double formula, because double angle, because our left side we have the double angle, in the right side we have the half of that angle, however you take. Now, if we apply this formula of the sine 2 theta here again, the angle is going to be half, which is x, and that's exactly what we need for the right side. Even if we apply the formula for the cos 2 theta here, angle will be half, and that will be, in terms of cos theta or sine theta. So let's write this formula and see what you get. So here, sine theta can be written as sine 2x. I'm sorry, so sine 2x can be written as 2 sine x times, because we are applying the double angle formula again for sine 2x. This is what we get for the sine, right? Again, the same formula for the double angle. Now the cos 2x, let's write the formula for cos 2x, which is going to be cos square x minus sine square x. That's the, these are the original formulas. I'm saying the original formulas for the double angles. So these are the formulas we are applying. Now, if you look at the step, look at the current step we are in. At this point, our angles look exactly fine. These are the angles we are looking for. Now, all you need to do is just open the brackets and distribute and multiply everything. Basically, you will be distributing your sine 2x cos 2x here. Sine is 2 sine x cos x, 2 sine x cos x here. So you just multiply everything with that. If you do it, it will be 2 times to 4. Let me do it one more step. In one more step, sin x cos x times cos square x minus sin square x. If I open this bracket, it will be 4 sin x times cos cube x minus 4 we are almost done. If you open the bracket, what happens? You just multiply everything. So it's like 4 sin x times cos cube x, because you have 1 cos x here, cos square x here. And if you multiply with these, it will be 4 sin cube x, because you have sin square here and sin x here, and cos x, so you are done. That's what exactly you had on the right side. Any question here? So we just applied the formulas, nothing else. And in all of the problems in this chapter, you have to be careful about the angles, because every time you are applying the formula, your angles are going to be half. Or if you do the vice versa, angles will be doubled. For an example, if you just write 2 sin theta cos theta, if you write sin 2 theta for that, your angles are getting doubled. So now it depends on what you are looking for, and based on that, what formula you are going to apply. And in some cases, you need little practice and little tricks, because for cos 2 theta, you have 3 different forms, right? So you could have applied any of this here, but if you apply the other 2, you will not get it right away. Probably you have to do some more steps to get this one. So that probably is some kind of probably practice. You'll guess it from here, because just looking at the right side, I know that since I need the cos cube there and the sin cube there, I know that something has to be square for cos and sin. That's what I guessed, and that's why I apply this one. Instead of that, if I apply like 2 cos square minus 1, then I will get probably something else, and then I have to do some more steps to get into this answer. This is probably the easiest I can think of right now. Alright, so let's try this one. Again, as you know that we have just like not too many formulas, right? We have only formulas for cosine, sine and tangent. Just looking at this one, you probably can guess that we will be applying cosine. Now the question is how? How you can apply cosine here? The interesting part is, if you look at here, is cosine 3x. So what we can do? What is your option? Don't forget that you can always apply the formulas from the previous sections. Don't forget that you always have to apply, you can always apply any formula, from anywhere you have learned so far. So, cosine 3x, probably there must be several different ways of doing the same identity, but I always try to explain what I understand and what I think easy. So one of the option is, if you just think the cosine 3x as cosine x plus 2x, okay, and then you can from there you can apply the formula for cosine alpha plus beta. Remember, there was a formula in the last chapter. That's also here in the page 4. That's under the other trigonometric identities, sum and difference formula. And the page number 4, last page, if you look at the last page and bottom left corner, you'll get that formula. So you can always write that cosine 3x as cosine x plus 2x, and then see how what you come up with. You may also notice one of the thing in the right side is everything is in terms of cosine. Okay, so whenever you are applying the formula, keeping in mind that everything should be in terms of cosine. So for an example, whenever you are applying, if you have to apply the formula for cosine 2x, because you might have some cosine 2x there, right? So don't apply the formula, this formula. You probably should have considered this one, the 2 cos square x minus 1. You know there is a form like this, because you will have to have everything in terms of cosine, right? So you will always prefer cosine over sine, but you probably will not be able to do that every time, but you can always get cosine from sines. I'm saying if you have like sine square, you can get 1 minus cosine square from there. So everything should be in terms of cosine. First step would be just write cosine, either options. There are two options. Either you can write, let's say, cosine x plus 2x, and then write the formula for that, which is cosine alpha plus beta. And then later, when you will have cosine 2x, because you always want to make sure that the angle is x, because if you look at the right side, all of the angles are x. So if you have something cosine twice x, you will apply the formula 2x square minus 1. I think after that, rest will be simple. Do some algebra. Any good news? Let's try it and see whether. So it's cosine 3x. We first write it as cosine x plus 2x. And then we apply the formula for cosine alpha plus beta, which we have learned in the last section. If we do it, we get cosine x times sine 2x minus cosine 2x times sine x. Alright, then here, now you can apply, okay, so now you can apply the formula for, let me check. Okay, I think this cosine, right? This cosine. And all these are sines. We gotta put this formula. Okay, now this is the formula for cosine alpha plus beta. Now you have some angles x at this point, but some other angles are still 2x. So your first objective is to make everything in terms of x, because in the right side you have everything in terms of x. Now remember, this is the way I think I try to make it easy, because I always think that what is the angle in the right side, so that I understand that what formula we should proceed on. one of the reasons I did not apply any formula from this chapter at the beginning, because I know that any chapter, if you are applying any formula you are applying here for cosine, that will make your angle half, right? And then what might happen is, since your angle is 3x, it will become 3x divided by 2, which will not good for the right side, because in the right side, once you have 3x divided by 2, that's your angle, which you'll not be able to get there, because it's like 1.5x. From 1.5x, it will be really hard to go to the x directly. You see what I'm saying? That's why I did not apply any formula from this section at the beginning. Now I'll be applying for sure, because here at this point, you have some x, you have some 2x. Now the ones with the x, you are fine with them. You don't have any problem here. The problem is the 2x ones. Now we'll be applying some formula from this section, because we know that the 2x divided by 2 is x, which is simple. So let's apply those formulas here. But I would always prefer for cos 2x, because you know for cos 2x you have several options, right? You have 3 different forms. But I would always prefer the formula in terms of cos only, because in the right side everything is cos. You can apply the other ones, but it will be a little bit longer. So I'm applying 2 cos square x minus 1 for cos 2x, because we want everything in cos in the right side. Now here, for the sine 2x, you don't have that many choices, because you just have one formula for that, so you have no choice left. So we'll be applying that formula only, which is 2 sine x times cos x, and you have sine x here multiplied with that. Now let's break everything down and see what you get. You have cos x times, 2 cos cube x minus cos x minus 2 cos x sine square x. Now at this point, if you look at the right side carefully, everything is almost okay except sine square x, because we don't want anything in terms of sine in the right side. So let's see whether we can always change the sine square x into cos square x, right? Because we know that sine square x is nothing but 1 minus cos square x. So let's do that, because you know we are applying the formulas from the previous sections. It's not only about this section. So cos cube x minus cos x minus 2 cos x. Now we are replacing the sine square x by 1 minus cos square x, because we want everything in terms of cosine in the right side. Let's see where we are right now. 2 cos cube x minus cos x minus 2 cos x plus 2 cos cube x. I think we are done, right? Just add and subtract. If you do it, you will have 4 cos cube x minus 3 cos x. See, I can solve the question always, but I always wanted to share that how I thought when I tried to solve it. So let's do it again. Let's try to see what we did. When I saw cos 3x, I did not choose to apply any formula from this section, because any formula here will divide the angle by 2. Now since you have 3x, and if you are dividing it by 2, it becomes 3x by 2, which is a little bit odd, and that doesn't seem to me that we are going toward x, because whenever you have 1.5x, you are not going towards 1. So that's why what I did was I choose a formula from the previous sections, which basically applying which we can divide the x into x and 2x instead of making it to half. You see what I'm saying? That's why I applied that. Once I applied that, it was simple, because some of the angles are already x, and if we look at carefully, I have never tried to change the x's. The only ones I tried to change was the 2x. So what I did was I applied the formula for 2x. While I applying the formula for cos 2x, I preferred 2 cos square minus x because I wanted everything in terms of x, cosine at the right side. Because I have 3 choices at this point. So I choose the one with cos only because I want cos in the right side. What happens if you don't choose this one and if you choose something else? You will still have your answer, but again, you probably will have little bit longer steps. Now, in the right side, I have sine twice x. I don't have any choice because I have just only one formula for that. So I just applied that. And then at some point, I found that all the angles are x, so I don't have to worry about the angles. The only thing that was not compatible with the right side was sine square, because in the right side, everything was defined in terms of cosine. So I just changed this to sine, and the rest was just algebra. Okay. So I'm just trying to show you that what exactly I thought when I was trying to solve it, and why I started like that, instead of going by any formula from this section. Okay. So you always have to think like that. You always have to find the best formula for you, because whenever you have a lot of formulas, you will always look at your right side and then decide where you want to go. Because anytime you apply any formula from here at the beginning, that will mess the whole thing, because you just get like 3x divided by 2, which will make it complicated. Any question here? So whenever you will be practicing this question, the best would be just look at the question and look at the formulas and think which would be the best formula you will start with. Okay, a lot of times you might have something which is like a dead end, so you can always backtrack from there and start over. Okay. How about this one? Cot x minus 2 cot x, cot 2x. Now here in this section we have only tried 3 trigonometric functions, right, for the double entry. So there was no formula for cot x so far. So what is the best option then? In the right side you see there is a tangent, right, and the angle is x. That gives you a lot of clue. What do? You can always write cotangent as tangent, right? Because cotangents and tangents are reciprocals to each other. So you can always start from there. You can just write cot x equals to 1 over tangent x, because they are reciprocal. And once you have tangent, rest is simple, because you can see that the right side you have tangent x. Okay? So all you need to do is you have to apply the formula for tangent 2x only. Remember, don't apply the formula for tangent x, because if you apply the formula for tangent x, your x is going to be half, which will make it tangent x by 2. Right side, no clue. So don't apply the formula. So be careful about that. You have to understand when you want to apply the formula on which one, because you always want to make sure that the angles are same in the right side and right side, and you are heading towards that point. So you will have a, from cotangent 2x, you will have 1 over tan 2x, right? Apply tan 2x formula there, so that it becomes tangent x. Let's see whether you can do it, and let's see whether we can solve it and we can get the answer. Alright, so here, let's see whether we can apply. So cot x equals to 1 over tan x minus 2 over 2 tan 2x. So we just, because tangents are and cotangents are reciprocal to each other. Now, we'll not be applying anything to tangent x, because we don't want to change it. Because anytime you apply the formula from this section, this angle is going to be changed, and we don't want to change the angle, so we are not applying anything here. But we always want to apply a formula to tan 2x, because we want to make it x, right? So to do that, what we can do? we apply the formula here, so just keep it as, let's keep it as 10x minus 2 over, if you apply the formula, it's going to be 2 tan theta over 1 minus 10 squared theta, right? Oh, not theta, it's x. 2 tan x over 1. I just applied the formula. That's the formula we have. Now we have at least the same angle for all the tangent in the right side, which exactly you wanted in the right side. Now let's see what you get. So if you little bit simplify it, you will have 1 over 10x minus 2 10x 2 times 1 minus 10 square x. You can simplify it, but just by multiplying the denominator and numerator by 1 minus 10 square x. Now let's take the common divisor and see. So common divisor is 2 10x, and this becomes 2 minus 2 times 1 minus 10 square x. Two 10x minus 2 plus 2 10 square x. Now the 2 and 2 get cancelled. So at the numerator you have 2 10 square x. Denominator you have 2 10x. If you cancel, you will be left with 10x only, which is the right side. So all these are from the applying the double angle formulas. Okay. So this was the previous one. So that's again the same question. But here, this is also simple. All you need to do is it's already given to you. If you look at carefully, if you assume that the x is your pi by 2, the pi by 8 is going to be tangent. It's basically the formula, right, for tangent 2 times pi by 8. So if it is tangent 2 times pi by 8, the formula, that's for the, if you assume that the theta is here, the theta is pi by 8, is going to be tan 2 theta, which is tan 2 times pi by 8, which is tan pi by 4, which is 1. Because tan 45 is 1. This is just like just the formula directly given to you. Any question here? And the last one, this is also extremely simple because all you need to do is just assume that 22.5 degree is your theta. So you will get like tan 2 theta, which will be tan 45, because 2 times 22.5. Here, if we assume that the theta is 22.5 degree, if we assume that the theta is 22.5 degree, from here you will get tan 2 theta, which will be tan 2 times 22.5 degree, which is tan 45 degree, which is 1. Tan 45 equals to 1. Any question? If not, we'll probably stop here. From tomorrow, we'll start discussing about the power reducing formulas and half angle formulas for the same section, okay, which is section 5.3.